Today we're going to be classifying quadrilaterals and looking at the properties of parallelograms. A parallelogram is a quadrilateral with both sides, pairs of opposite sides parallel. So that would mean our top and our bottom are parallel, as well as our left and the right. A rhombus is a parallelogram with four congruent sides. So if it's a parallelogram, it has two sets of parallel sides, and it has four congruent sides. So all four sides are congruent to each other. A rectangle is a parallelogram with four right angles. So it has two sets of parallel sides, and it has four right angles. A square is a parallelogram with four congruent sides and four right angles. So a parallelogram, so it has two sets of parallel sides, has four congruent sides, so four sides that are all equal, and it has four right angles. A kite is a quadrilateral with two pairs of adjacent sides congruent and no opposite sides congruent. So my adjacent sides are congruent to each other. A trapezoid is a quadrilateral with exactly one pair of parallel sides. So I only have one pair of parallel sides for a trapezoid, and an isosceles trapezoid is a trapezoid whose non-parallel sides are congruent. So we still have one set of parallel sides, but our opposite sides that are not parallel are congruent to each other. So we're going to use a Venn diagram to determine which one of these is incorrect. So this is saying that rhombuses are parallelograms. A rhombus is a parallelogram, so this is true. Here we're looking at saying that squares are rhombuses. Well, a square is a parallelogram with four congruent sides, and a rhombus is a parallelogram with four congruent sides. So squares are rhombuses. Rectangles are squares. So a rectangle is a parallelogram with four right angles. So a rectangle is not a square because the square has four congruent sides and the rectangle does not. So this one is incorrect. Let's just look at the last one. A kite is a quadrilateral. A kite is a quadrilateral. So this one is also true. So judging by appearance, we're going to classify W, X, Y, Z in as many ways as possible. Well, it looks like it's a parallelogram because it looks like both sets of my sides are parallel. Looks like it's a rectangle, and I do know it's also a quadrilateral because it has four sides. So we want to find the value of X and Y and then find the lengths of each side. So if I take a look with this is a kite, I have two adjacent sides that are congruent. To find my Y, I would do Y minus 3 has to equal 6 because these two side lengths are congruent to each other. So if I add 3 to both sides, Y equals 9. So now if I'm going to find X, this is 2X plus 3, and it's Y plus 2. So I know these two are congruent to each other, so if I have 2X plus 3 equals Y plus 2, what I'm going to do is my Y I already found was 9, and I'm going to plug that in for my Y. So I have 2X plus 3 equals 9 plus 2. Well, 9 plus 2 is 11. So 2X plus 3 equals 11. Subtract 3 to both sides. So 2X equals 8. Divide by 2. X equals 4. So then it says, then find the lengths of each side. Well, I know this side is 6, this side also has to be 6 because they're congruent. And if I did 9 minus 3, I would get 6. Here, when I plugged in my y, 9 plus 2, that means this length is 11. So this length also has to be 11. So let's identify some theorems. Theorem 6-1 states that opposite sides of a parallelogram are congruent. Theorem 6-2, opposite angles of a parallelogram are congruent. In Theorem 6-3, the diagonals are bisected. Oops. So looking at example 4, using the properties of parallelograms, we want to find the values of x, y, and z. Well, if I'm trying to find these, according to Theorem 6-2, opposite angles of a parallelogram are congruent. So if I'm looking here at finding angle z, this is my opposite angle, so they are congruent. So that means z is 122 degrees. When I am looking for, I should probably write measure of angle z is 122 degrees. The measure of angle x, if I'm looking here at x, I actually have a set of parallel lines. So if this is one parallel and that's the other, this is my transversal. So I have alternate interior angles. So that means x is going to be the same degree as 32 degrees. So x is 32. So then to find the measure of angle y, I am dealing with a triangle. I know 3 angles add up to be 180. So if I do 122 plus 32, I get 154. And when I subtract from 180, I get 26. The measure of angle y is 26 degrees. So using the properties of parallelograms, I want to answer each of these questions. So this is on my diagonals. So what segment is congruent to XW? So XW is right here. According to 6-1, opposite sides of parallelograms are congruent. So XW would be parallel to this, and that would mean that YZ is what it's congruent to. What segment is congruent to YN? Well, here's YN, and since it's stated here in Theorem 6-3 the diagonals are bisected, that means they're split in half. That means WN is what it is congruent to. And lastly, what angle is congruent to XYZ? XYZ, so this angle right here. According to Theorem 6-2, opposite angles are congruent in a parallelogram. There's my opposite angle. So angle XWZ. So example 6, we're using properties of parallelograms, and we know that the measure of angle 1 is 114 degrees. So I know this angle right here is 114 degrees. According to our Theorem 6-2, opposite angles of a parallelogram are congruent. Well, my opposite angle is right here, angle 3. So that means angle 3 is also 114 degrees. So then I need to find the measure of angle 4 and a measure of angle 2. Well, I know that these two sides are parallel. So that means this coming down here is a transversal. So we are dealing with same side interior angles, which means that the measure of angle 4 and the measure of angle 1 have to add together to be 180. So if I do 180 minus 114, we end up with 66. So that means the measure of angle 4 is 66 degrees. The opposite angle in a parallelogram is also congruent, so the measure of angle 2 is also 66 degrees. So for number 7, we're going to be using some algebra. We're going to find the values of x and y. First of all, though, this is going to be 3y minus 11, y minus 1. We're going to change this one to be y plus 1. And then this is 2x minus 1. So I know that I have my diagonals, which means that they're being bisected. So that means that this is congruent to that one and these two are congruent. So when I go to first start to solve this, I'm going to start with this diagonal because they're both dealing with y's. So I know they're congruent, so I have 3y minus 11 equals y plus 1. So if I go to solve this, I'm going to subtract y to both sides. 2y minus 11 equals 1. Add 11 to both sides. 2y equals 12. Divide by 2. Y equals 6. So then next, I want to find my x value. So I'm going to deal with my other diagonal that's being bisected. So 2x minus 1 equals y minus 1. We just found out that y equaled 6, so I'm going to substitute 6 in for my y. So I have 2x minus 1 equals 6 minus 1, and I know 6 minus 1 is 5. So if I add 1 to both sides, get 2x equals 6, divide by 2, x will equal 3. So now we are going to identify theorem 6.4. It states if 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. So using that theorem, let's look at example 8. So in the figure, the horizontal lines are parallel. So I know all of these are parallel to each other. And AB, right here, is congruent to BC, which is also congruent to CD. So according to this, if the segments that are cut by a transversal are congruent, then all the transversal ones are also congruent. So if I'm looking at trying to find JK, JK is this distance right here. I know from M to L it's 4, so that means JK is also 4. So now I want to find the length of GH. GH is right here. I know that from E to F it's 5.5, which means this is 5.5. So that means GH is also 5.5.